Good day, everyone. Welcome back to my YouTube channel, an outstanding chemistry channel, giving outstanding information, especially in chemistry. My name is Ayodele D. Kazumi, chemist by profession. Okay, today's topic is going to be on why chemistry practical for alternative B, of course, 2024. Chemistry practical alternative B is here. On the 20th of this month, of course, there is going to be an examination for practical exam chemistry alternative B. It's taking place on the 20th of this very month. So today we'll just be looking at some predictions questions on titration. Okay, I'll be basing my discussion, the experiments today, calculations on titration. So some other videos will come with short analysis. Okay, very soon. So let's see what we have today. So let's start with the acid for this experiment is going to be labeled D, and the acid is HNO3 trioxonitrate 5 acid, and the given value is 5.0 cm3 to be dissolved in 1000 cm3 of water. And we have E as the label for the base given, which is sodium trioxocarbonate 4. That's Na2CO3. We are given 3.5 gram to be dissolved in 1 dmq or 1000 cm3 of water. So for tutors, for teacher preparing students for this particular examination, you need to know, have a range of the titration, the expected titration value, and that's why I've taken time to explain and show us how to arrive at a calculated theta value for this particular experiment. Okay, let's use dilution factor. Dilution factor formula is C1V1 and C2V2. Now our C1 is 15.5 mole per dmq. Is not in this particular question, but it is an experimental determination from say stock preparation in chemistry. Okay, I can refer you, beg your pardon, to a chemistry textbook by a mentor, Dr. Jokuku Godwin. Okay, it will show you this particular value and some other values that you need to know on chemistry practical. Now let's look at the volume of the acid. There is given is 5.0. Okay, from the yellow paper. When you check it, you see it there, or you see one up there. While we are looking for the Conc2 C2, and our V2 will be what we are going to be diluting the volume of the acid to. So 1 dmq, which is equivalent to 1000 cm. So if you substitute that value correctly, we'll have something in this nature. And making such a formula, our final answer will be 0.0790 mole per dmq of HNO3. Of course, there's going to be a balanced chemical reaction that I will show you below between the acid and the base. So this is the base we are going to use. All right. So calculating the molar mass for the base, we have 2 moles of sodium times 2. The value is 23. The value of carbon there is 12. Value of oxygen is 16 times 3. Everything 106. So let's use this formula to get the mole per dmq of the base. 3.5 divided by 106. Then we have 0.0330 mole per dmq. This is of what? This is of what? Of B. So we can call this one C. Okay, while we can call this C D. Okay, let's really go down to see a formula. Let's use this formula. Okay, we can use kava since kava can be for the one for CAVA, but now it has changed. Alternative B is going to be CDVE. Okay, so that you not confuse anybody, because the labeling you're going to see on the beaker we are going to use is going to be D and E. All right, this is for the acid, this is for the base, this is the volume of the acid we want to determine. Okay, this is the volume of the base, that's the pipette volume. Okay, you can either use 20 or you use 25. Okay, in my own school and for this experiment, for this practical class, for this calculation teaching, I'm going to be making use of what 25 cm cube, and the mole ratio of acid to base from the balanced chemical equation, which I'm going to show you below, is going to be 2:1. 2:1 is 2:1. Beg your pardon. It's 2:1. This is 2. And this is, let's clear that one quickly. This is 1. Balance that chemical equation. And this is going to be 2. And that will be 1. So you can see, yes, you can see from the balanced chemical equation. All right. You can see it from the formula. Okay, let's quickly substitute the value. Substituting this value, we have this. All right, and we have our final answer, which is the volume of the acid. That's Vd calculated value to be 20.90 cm cube. So we are using 20.90 for this experiment. I'm going to be using 20.90 cm cube auto. Let's take notes, please. I'm going to be using 20 point as my volume of the acid. Okay, it's going to be Vd now. Okay, so let's start with experiment 1. Experiment 1 titration. Let's look at D is a solution of 0.235 mole per dmq of HNO3, and E is a solution containing 14.3 gram of hydrated trioxocarbonate 4 in 500 cm3. Mind you, it's not in dmq yet, it's in 500 cm3. So the experiment say they will explain to you, put D into the burette and titrate it against 20 or 25 cm3 depending on your school. But for my school, I use 25 volume of the pipette. Okay, so all my students, if you're hearing me, you know me, make sure you use 25 during your practical. I wish you best of luck. So question of E, using methiorin as my indicator, repeat the titration to obtain consistent value and tabulate your reading and calculate the average volume of the acid used. So the balanced chemical equation here is this. Look at the balanced chemical equation. So we have acid, we are having 2:1. Okay, 2:1. You can see my balanced chemical because for this hydrated salt, it might give you hydrated salt or anhydrous salt depending. So after the titration, we arrive at this table of value. Raw VA is 21.00, first is 20.90, and second is 20.90, and third one is 20.80. Now, out of these 4 tables or 3 tables that you might prepare, WAEC only interested in 2 values. We call it 2 concordant values. Okay, and the rules for 2 concordant value is that the differences between the value I'm going to be using this one and this. The difference between them must not be more than plus or minus 0.15 plus or minus 0.15. Okay, I think I go use plus or minus 0.20. So look at my difference between the two is 0. So I'm good to go. So why could just give me 4 marks? Bam. They give me 4 marks here. All right, and they will give me my 1 mark. Bam. My 1 mark. And they also give me my 1 mark for my averaging. So I have free of charge 10 marks. So students, take notes. Please, students, take notes. Take note of this. That this aspect is a free for us to then make sure you don't cancel your table. Make sure you don't cancel. And make sure you do your table so I can have free of charge. So where the bulk of work is during the calculation. So let's quickly dive into the calculation. From the results and the information provided above, calculate what the concentration of E. Remember, your E now is the base in mole per dmq. At the same time, fraction of E in gram per dmq. That's the molar mass of the same E and the value of X in E. So let's see how to approach that. Let's see how to approach this. What solution? I'm adding fraction of E mole per dmq. I'm using this formula. Okay. All right. Of course, I have my ratio acid to base. I'll just substitute my value. Look at the value of the given value. This might look at my value for my volume of acid. I'm looking for question of E. So when I do all of that, WAEC normally will give me 1 mark here. For some of you that are very conversant with marking, that's for mole ratio. You also give me 1 mark here for me be able to substitute accurately the values that I have, and you also give me 1 mark here for me making CE sort of formula. And my final answer, they will give me 1 mark because it is in mole per DMQ and it's also to 3 significant figure. It's very important. Chemistry deals with details, simple details for us to get a value because we don't want to play, we don't want to downplay anything. So I think this is the value for mole per DMQ. That's correct. So let's move to a question of E in gram per DMQ. Our E we're giving 14.3 gram in 500. So I want to convert it to what? To DMQ, to DMQ. So we go through all this process, all right, and you have this conversion to be what? 28.6 gram per DMQ, which answer these questions. Are we good to go? Students, hope you are following. Hope you are getting it. Okay, let me know in case you don't understand in the comment section below how I will respond to you. All right, molar mass. Let's look at molar mass. Molar mass, the formula I'm going to use is the molar mass, which is going to be conc of E in gram per DMQ over conc of E in mole per DMQ. My conc of E in gram per DMQ is 28.6 gram per DMQ divided by my value. Remember, the value I got up is 0.0, you can see it, 0.0982 mole per DMQ. I'm going to put it there, so I have 291.24 gram per mole. Student, take notes so that you don't miss details. Mark here, for you to score, you need to have a correct unit, which is gram per mole. Remember, anytime you're working with molar mass is gram per mole, they will give you a full mark. So now I need to calculate the value of X. I need to calculate the value of X. All right, this molar mass, I'm going to equate all this to my molar mass. Then I substitute respectively the value of each element in that particular compound, hydrated compound. Now, for sodium is 23 times 2, okay, it's giving us 46. While 1 carbon, that's 12. And 3 oxygen is 16 times 3, 48. For the hydrated, this point in chemistry means addition, okay, X. So I have the value of hydrogen to be 1 multiplied by 2 plus 16. Everything is giving us 18 molecules of water. So all right, equals to our total molar mass. So adding all this together, I'm going to have 106 plus 18 values of X. So this is what I have, all total. So in all, I will do a mathematical calculation, okay, by sorting it out, collecting the like times of this value, then all I have this divide by both sides by 18. Doing that, I have 10. Okay, I can do an approximation there to what? To 10. So my X equals to 10. So I'm going to substitute the value inside the formula. So I have something like this. Is it not nice? The name becomes sodium trioxocarbonates what? Carbonate 4 decahydrate. Wow, this is excellent. This is excellent. I hope you are enjoying the class. Okay, hope you are enjoying the class. All right, follow me for more questions. Let's look at question number 2. Okay, question number 2. Question number 2 says D is a solution of 0.071 mole per DMQ of HNO3 and is a solution containing 0.0300 mole per DMQ of trioxocarbonate. Now, in these particular equations, we are only giving HNO3. We are not giving the formula for the trioxocarbonate 3. Trioxocarbonate 3 can be sodium trioxocarbonate 3, can be potassium trioxocarbonate 3, can be magnesium trioxocarbonate 3, can be calcium trioxocarbonate 3. But specifically, this question does not give us a clue on the exact trioxocarbonate 3 we are dealing with. So let's follow the questions the whole thing the way we did in that place. So all this can jump all of that, the same thing. Remember, we're going to be using our this to be what 20.90. So let's look at the question to approach. So from the result and the information provided above, calculate the mole ratio. Look at it. The mole ratio of acid to base. So in calculating the mole ratio, there are certain things to give or to pay a little attention to. Okay, let's look at number 2. Given that E contains 5.7 gram per dmq of hydrated trioxocarbonate, calculate the concentration of anhydrous. Anhydrous is the dry one. Anhydrous salt in E and the percentage of water of hydration in what? In E. Imagine, you are not even given E. We don't know what is inside E. We just know it is trioxocarbonate, but we are sure of E that is HNO3. Okay, let's go. And number 4, the number of moles of hydrogen ion in the average titer. This question is loaded. So let's see the way to approach such questions if it comes out on the 20th of this month. So number 1 thing is to calculate the mole ratio of acid to base. In calculating the mole ratio of acid to base, formula to be used is amount in moles equals to concimo per dmq times volume over 1000. Of course, we have acid and base, which is D and E. So we want to calculate it separately. So this one is for acid. Okay, the value for acid is this multiplied by the volume of the acid, the calculated value, divided by this. So we have this for what? For our acid. Beg your pardon. It's supposed to be what? D for our acid. For our acid D. Thank you. So let's the next one. Okay, for E now. Okay, for E now. Let's look at that. For E we have the same value 0.0300 times 25. 25 is the volume pipetted divided by 1000. All right, everything will give us this. Can you see now? Now, successfully now we have the mole of the acid and the mole of base. So, but the question says, what is the mole ratio? Let's get the mole ratio. The mole ratio, how you get the mole ratio? This is the mole ratio 0.00150 of the acid and 0.001750 of the base. Now, what you're going to do, divide by the smallest. The smallest here is this for the base, it's the smallest. So divide by the smallest, you have 2:1. Therefore, it shows that your acid is 2. When you balance it, remember our acid is HNO3 and our base is what? Na2CO3. When we balance their chemical reactions, you will see that it's going to give us 2 of the acid and 1 of the base. I hope you are following. Okay, let's quickly go to the next question. The next question is a calculate question of anhydrous salt in E. You can also use this formula to do that. Okay. Now, the value of anhydrous has been given to be 106. Okay, check the question. If it's not given, anhydrous given is 106. Multiply by the value of E given. When you multiply, you have this 3.18 gram of the dry salt. Now, what is the percentage of the hydration? Okay, remember the value. Let's go back quickly to the value given up. You can see the value here, see the value for the anhydrous and see the value of the hydrated trioxocarbonate to be 5.0 gram per dmq. So back to our questions. All right, you can see it there. We want to calculate the percentage of water of hydration. So the mass of water of hydration is we are going to deduct 3.18 from the given value. So give us 1.8. So calculating the percentage, that's over the total multiplied by 100, giving us 36.4% of the hydration, water of hydration. So finally in these questions, they said we should calculate the number of mole of hydrogen ion in the average titer. Okay, molar mass of this, we know that already. Given, okay, to be 100, we don't even need it again, 106 rather. 106 gram per mole. Right. Okay, now look at it now. Look at this reaction. That's it. Now, 1 mole of HNO3 contains 1 mole of H plus, according to this ionic equation you are seeing. All right. Now look at it. 1000 cm³ of D contain what? Contains 0.078 according to the question. All right. Now that means 20.0 of D will contain what? We contain what? We contain this. So I want to say 20 multiplied by what? 0.08 mole. Okay. Divided by what? 1000. That give us 0.01500 moles of what? Of hydrogen ion. Of what? Of hydrogen ion. Wow. Excellent. Excellent. Hope you are enjoying the class. In case you have a questions and the area you don't understand, you can leave them in the comment section below, and maybe I'll leave my number for you to just contact me for more explanation. Okay. Question number 3. Just stay tuned. Just stay tuned. You enjoy it because we do it outstanding here, and want our students and our tutors to train our children for a better future, and our students to also perform excellently well. Okay, excellently well. That's what we are. That's what we stand for on this channel. Now let's look at question number 3. D is a solution containing 0.113 mole per day of HNO3, and E is 13.5 gram of another hydrated salt. Okay, the question is still remain the same. Do the same thing, titration. This is the balanced chemical equation. This time around is quite different from what we have before, and we have our titer value also here. Okay, now see where our interest is, because everybody now know how to handle table. Okay, but repetition, okay, is the mother of mastery. Okay, from the results and the information provided above, calculate the coefficient of E in mole per dm³, molar mass of X2CO3 dot 10H2O, and percentage by mass of X in X2CO3. X2CO3. You are not there. X2CO3. Okay. Let's go back. H2CO3. Okay, good. Now, okay, you can see the X2CO3. Okay, let's see how to calculate it now. Okay, number 1. Coefficient of E mole per dm³. Now, using this same formula. Okay, all of that. You have substitute correctly the value of coefficient of the acid, volume of the acid, radical of E, then mole ratio, then we have our final answer to be 0.0472 mole per dm³. For you as a student, I will try this thing myself. So we are done with the value of that one. What is the molar mass of this? Since we know this one now, we are going to be using this formula. Molar mass is equal to conc in gram per dm³ over conc in mole per dm³. Our conc gram basically is 13.50. Remember, divided by the calculated value we have here, which is 0.0472 mole per dm³. So we have this to be our molar mass. All right, this molar mass now, we have to calculate the percentage of X in this X2CO3. Now, what's the percentage of X now? We equate the hydrated salt, okay, to our molar mass, 286. 286. This should be 6. 286. Right, 286. No, we have this 2x, okay, plus 12 for carbon, plus 16 times 3, that's for oxygen, and 10 molecules of water. Then everything give us this 286. So this plus this plus this plus this plus this equals to this, rather 180 now. 10 times 18, 180. 12 plus 48, 60, 180. So add this thing together, we have 240. Then collect the like times. Then we have 286 minus 240. Then what we have there, we have 46. Okay, we have 46. Now, that's our x. So 46 now, this is supposed to be x. Then without our graph equation, we have our 2 here. So divide both sides by what? By 2. Okay, divided by 2, we have our x to be 23.0. Okay, 23.0, that's our final value for x, 23.0. Now, so to calculate the percentage by mass of x, remember the formula is X2CO3. Okay, we have 2x in that particular reaction. So we are going to multiply x by 2. So our x, which is 23, the value times 2. X, so we have 46 times 100 divided by what? 286. So our final answer is going to be 16.1% of what? Of x. Remember, the yellow in the yellow paper, the value given is the base given is Na2CO3. And when you look at the value of x, it's also tally because sodium is 23. Okay, so make sure you take note of that. So let's go to experiment 4. Experiment 4 is this a solution containing 15.1 gram per dmq of HNO3 and it contains 10.6 gram of H2CO3. Wow. Okay, this is a balanced chemical equation for this particular experiment. 2 moles of HNO3 reacting with 1 mole of X. CO3. In this question too, we don't know what X is. So let's see what the question will tell us to do. So these are volume of acid we are using, which is tagged as what? VD. Okay, because this is representing the acid in this particular experiment. So from the result of the information provided above, calculate conc of D mole per dmq, conc of E mole per dmq, molar mass of X2. It's a straightforward questions. So the first thing we do is to get our molar mass, because the formula I'm going to use is conc of D mole per dmq. Look at it, equals to conc of D gram per dmq over molar mass. So our molar mass can be calculated. HNO3, that's 1 for H, 14 for N, and 16 for oxygen, but with 3 molecules of oxygen making 3. So we have 14 plus 1 plus 48, giving us 63 gram per mole. Remember your unit count in chemistry practical. So let's substitute the value. The value for D up is 15.1. We divided by 63. So we have 0.24 mole per dmq. Now for conc of E mole per dmq, since we have the value of the D, okay, in mole per dmq, we can use CdVd over CeV equals to ND over NE. So let's substitute it correctly into this formula. So we get this, pick your calculator and confirm that. Then we have our final E to be what? 0.100 mole per dmq. So how do I calculate my molar mass for this reaction? So I can use that formula again. Mole per molar mass of X2CO3 equals to conc in gram per dmq over molar mass. You already have my conc in gram per dmq to be 10.6 divided by conc in mole per dmq, you have 106. Okay, it's making sense. Italics. Now remember, the value given is what? Na2CO3. So if you substitute the value of that, you have 106. It's making sense. Hope you are following me in this practical class. Hope you are following me in this practical class. So let's go quickly go to experiment 5. But rounding up, make sure you watch this video to the end. It will help you as a student. It will help you, honestly, it will help you as a student. All right. D is a solution containing 6.3 gram per dmq of HNO3, and E is a solution containing Na2CO3. Put D into the burette and all of that, and we have that. Our equation still remains this. Our table of value, the table of value is still this. The value of D we are using acid we are using is 20.90 as said earlier. So let's look at the main questions to solve this time around. Say calculate concentration of E mole per dmq, conc of E in gram per dmq, and mass of sodium ion in 1 dmq of E. Alright. Our molar mass again give us this. You should know that by now. You can use these are gram per dmq giving 6.3 divided by 6 calculated one. This giving us 0.1 mole per dmq. Okay. Now doing that, we are going to have this. So 0.01 of D. Now 0.01 of D multiplied by this. Okay, this was giving us conc of E in mole per dmq. This C E in mole per dmq. Okay. Now because we don't have it in mole per dmq, we have to convert gram per dmq actually to mole per dmq. We have to convert it to mole per dmq. All right, we have that conc of E mole per dmq to be this. Now let's calculate our conc of E in gram per dmq. So Na2CO3 Na2 is this 23 times 2 plus 12 plus 16 times 3, everything give us what? 106. So 106 now, we are going to multiply it by the value of 0.0418. So we have this. Then our final answer in gram per dmq is 4.43 gram per dmq. Okay. All right. Now let's calculate the mass of sodium ion in 1 dmq. Very simple. So we are going to ionize our, we are going to dissociate, let me use that word, for our Na2CO3 to have Na2 plus, then there will be 2 molecules of ion here, of sodium here, then we have plus CO32 minus. So from that particular equation above, we see that 2 moles of sodium ion are involved. So 2 moles times the value we have, see this value times this value up here, the value of E. Remember we have the value of E here, yes, times this value. Okay, I hope you are following. Please stay tuned, don't be confused. So we have that. So our final answer here, we have 0.0836 mole per dmq. So to get the mass of ion in 1 dmq, you remember 1 dmq is equivalent to 1000 cm3. So let's use this simple formula. Number of moles is equal to conc in mole per dmq times volume over what? Over 1000, which is also number of moles is equal to mass over molar mass. So we can replace number of moles to be what? Mass over molar mass. Conc in mole per dmq times volume divided by 1000. My mass, that's what I'm expected to calculate. So my molar mass of sodium is 23. But the value I got from my equation of ion of sodium ion is 0.0826 multiplied by what? 1000 divided by 1000. Of course, I'm using in CMQ now. So I have my final mass to be what? 1.92 gram. So another experiment now is experiment 6. Experiment 6. D is a solution containing 1.4 gram of HNO3 per 500 cm3 of solution. All right, follow me, please. Make sure you follow this experiment. You're almost done. We're almost done. So 1.4 of HNO3 now is going to be dissolving in 500 cm3 of solution. All right, while the basis was prepared by diluting 500 cm3 of a saturated solution of Na2CO3 at room temperature to 1000 cm3. So when you put the same thing we have been doing, be giving you directives on how to perform the experiment. Okay, the balanced chemical equation is this. This balanced chemical equation. That's our ratio of acid to base is 2:1. All right. Quickly now, we are using the volume of acid to be what? 20.90 cm3. Now, let's look at the calculation. From the result and information provided above, calculate the concentration of D mole per dmq. That's question number 1. Concentration of E in gram per dmq and solubility of Na2CO3 mole per dmq. Volume of CO2 that will be liberated from 1 dmq of E in the titration when we are trying to carry out at STP. Remember, at STP. Remember, at STP. All right. Now, the first thing to do is to convert the value of 1.04 of D given in 500 to DMQ. So we are going to have, after our conversion, okay, to gram per DMQ, you will have 2.08 gram per DMQ. So you didn't need to calculate your what? Also your molar mass of HNO3. Wow, wow, wow. Hope you are following. If you have not subscribed, please do well to subscribe. If you have watched this channel, just pay attention to finish this as a student. This is what you need for alternative B chemistry practical. Okay, thank you for staying tuned. So let's quickly continue. All right, you have calculated the mole, the gram per mole of HNO3. So let's calculate the mole per DMQ. All right, now we have 2.08 divided by 63, giving us 0.0330 mole per DMQ. All right, of, remember, of D. Okay, and we are supposed to calculate this. All right, let's use this formula for calculating the mole per DMQ of E. Follow this mole ratio, substitute the value of D. This is our average value of acid use. Then at the end of the day, we have our value of E to be this. Okay, mole per DMQ. We have answered two questions. So let's quickly go into the third question. Solubility of Na2CO3 in mole per DMQ. Let's quickly use dilution factor to do that. You remember, is 50 cmq that is dissolving in 1000 cmq. So let's use all of that. This is the value you obtain, value of conc of base, then in DMQ 1000, and this value you are looking for this. So you have to substitute. When you make substitute from formula, you have 0.276 mole per DMQ for your solubility. So how do we calculate the volume of the CO2 that is liberated in 1 DMQ of E from the balanced chemical equation at STP? Remember, at STP, the volume is 22.4 DMQ. Remember this value? This value obtained from concentration of E in mole per DMQ or above. So we are going to take it to mole, and in doing that, we are going to use number of mole is equal to conc mole per DMQ times volume over what? Over 1000. But this time around, we have 1 DMQ volume. 1 DMQ is equals to 1000 CMQ. So we can have this value to be 0.0138 moles of Na2CO3, which is our E. So we have successfully converted. This one is in mole per DMQ to what? To mole. Now, from our balanced chemical equation now, okay, which is 2:1, this one, which is 1 mole of Na2, right, can produce 22.4 what? CO2, which is our carbon dioxide liberator. That's what we are looking for. So the mole obtained from up here, now we'll bring it down, you produce what? X. So when we make X the subject of formula, okay, when we make our X the subject of formula, then what do we have? We have 0.13 multiplied by 22.4 over 1. So our final answer, okay, give us what? 0.30912 DMQ of sodium carbonate. All right. Okay, you're waiting enough. I know you will pass this exam in flying colors because these questions are well selected. And number 7, experiments to wrap up today's titration practical class is D is a solution containing 0.10 mole per DMQ of HNO3 and is a solution containing 2.5 gram of mixture of Na2CO3 and Na2SO4 at 250 cmq of the solution. Okay, and the molar mass given is 106 gram per mole. All right, this one is our equation. By now, everybody should know this equation of R, and this is our calculated value by now. we should have mastered this. So let's look at the question. Concentration of E mole per dmq, conc of Na2 in gram per dmq, percentage of Na2 in the mixture. Remember, we mix Na2CO3 plus Na2SO4. Okay, let's quickly calculate that. Since we have that, we have the D in mole per dmq. Okay, we can use this formula. Okay, this formula will give us this. We just substitute the value 0.10 times 20.80 over E times 25, and all of that will give us 0.018, the mole per dmq of E, which is the base. Okay, now going to the second one, this one in gram per dmq. This is the formula for gram per dmq. We already given the molar mass to be 106. So just multiply 0.0418 times 106. You have your 4.4 gram per dmq. Now, how do you calculate the percentage of Na2 in the mixture? Remember, we have two mixtures. We have Na2CO3 in Na2SO4. Okay, let's first of all convert 2.5 given, okay, in 250 to what? To dmq to 1000. So converting that, when you do all of that, you get this value 10 gram per dmq. Now, how would I calculate the percentage of Na3? Remember, the value of Na2CO3 in gram per dmq now is this. Can you see it? Can you see, guys? 4.43 gram per dmq. All right, I'll just extract that one all over the total. The total is 10. Can you see it there? So I'll just extract it. 4.43 times what? Times 10. That times 100 divided by what? Divided by 10. So my final answer becomes 44.3%. Okay. Well, I want to appreciate you for staying tuned to the end of this video. I believe you have gained something, and I believe this information will help your alternative be practical. Okay, if you have found this video very useful, why not make a commitment by just clicking the subscription button, notification button, so that any other video I'm posting, you'll be the first to get. I'm signing out. Thank you for watching. See you in my next video. Bye.